Hey guys, welcome back. Today we are going to discuss about integration by parts. Now, on my previous video, I discussed about substitution rule. Now, integration by parts involve substitution but in a different formula. So I have here integral of f of x g prime of x dx is equal to f of x g of x minus the integral of g of x f prime of x dx. Now, f of x times g prime of x dx, integral of that is equal to f of x times g of x minus the integral of g of x times f prime of x. Now, to further understand that, we let the integral of u dv is equal to u times v minus minus the integral of v du. Now, we will use this entire formula. We will use this formula in solving integration by parts. So what if I have the integral of x sine x dx. Now, in substitution, in choosing what is your u and what is your dv, we need to take note of this. We need to take note of these liate. Logarithmic, this is in order, and I stands for inverse trigonometric. A means algebraic, and T is just trigonometric, and E is of course exponential. Now, for this problem, what could be our u? Now, x is algebraic and sine x is just trigonometric. Now we left, so our u is simply x. Now our dv is sine x dx. Now, the derivative of x is dx, and the integral of sine x would be negative cosine x. Alright, so we are going to follow this. From the given formula, we have u times v, so we have x times negative cosine x minus the integral of v times du, which is negative cosine x, and our du is just dx. Now, we get the integral we need to simplify this problem. So this is negative x cosine x minus cosine x. The integral of negative cosine x is negative sine x, right? So we have negative, negative, so we have positive plus sine x plus, this is x, some constant c. Now that is our final answer. Now what if I have, let's say here, I have the integral of t squared e t dt. So what could be our u? Let u, what is our u and what is our dv? Now t squared is algebraic, and algebraic here is on third place and exponential is on fifth place, so we will choose t squared as our t squared. dv is dv is e t dt, and the derivative of t squared would be 2t dt. This is dt, guys. Our integral for et is just et. Okay, now we will use that to get our final answer. So we have the formula u v minus the integral of, looks like x, integral of v du. Now our u is t squared. We have t squared e t minus integral of et times 2t dt. Now because we have a constant here, I would just like to do this. I have the t squared et minus 2 et times t dt. Now we can't get the final answer yet because we have ett here, so we need another integration by parts. Now our goal is, so we let u is equal to t, dv would be et dt, du would be dt, and v would be et. Now since we have du is equal to dt, we are 100% sure that this is our last integration by part, because we have this. So by the given formula we have set aside, we have t squared et minus 2, and then what could be our u? Our u is t et, am I right? Our u is t et. What could be our v? V minus the integral of et dt. Now we need to simplify these problem. So I have here t squared et minus 2, distribute the 2, so I have here 2t et, so I have negative 2 times minus 80, or just negative 80, so it become plus 2 et plus some constant c. Now this could be your final answer, but for me, because they have a common factor, which is et, I would gladly do this. T squared minus 2t plus 2 plus some constant c. Now this is your final answer. Now integration by parts, it's a little bit tricky, especially when you have encountered this problem, because there are integration problems, there are integral problems that will require at least 3 integration by parts, 2 integration by parts, and you need to be extra careful. Just follow the formula and apply your techniques in integration, especially when you have when it involves power rule. As I told you before, power rule is a pretty common strategy in integrating, and you will encounter power rule in most cases. So